Welcome. In this video, I'll be talking about the visualization when you have four lines equations in two unknowns. In the context of linear algebra, when you have four linear equations in two unknowns, the following is the scenario. We're going to talk about the row picture and the column picture. So please subscribe and comment. So in row picture, the four lines in a two represent is represented in a two-dimensional plane. Each equation represents to a line, and their intersection point, if it exists, would be the solution to the system. So the solution in two dimensions would be a point. So for the column picture is in a two-dimensional space because we're dealing with two unknowns. This involves visualizing the vectors that represent the coefficients of x and y. So what are the conditions for the solution to this system? The equation will have no solution unless the vector on the right hand side is a linear combination of the vectors formed by the coefficients of x and y. This means that the vector you're trying to reach on the right hand side must be expressible as a combination of the other vectors for a solution to exist. So let's look at an example to better understand this. So let's say you have this system here: 2x plus 3y equals 5, 4x plus 6y equals 10, x minus y equals 1, and 3x plus 2y equals 4. Let's look a little bit about the row picture. Each equation corresponds to a line in a two-dimensional plane. You will graph this line to see if they intersect at a common point. The column picture. The coefficients form vectors in a two-dimensional space. For instance, 2, 3, 4, 6, 1, negative 1, 3, and 3 and 2. The right-hand side vector 5, 10, 1, 4 must be a linear combination of these coefficient vectors for the systems to have a solution. So let's look at what they mean by that. That means that if we express if we express 2, 3 plus, and then we're gonna have coefficients here, so it's gonna be, let's say we have something like we call them, let's say, A 2, 3 plus B 4, 6 plus 1, negative 1, and then C plus D 3 and 2. There must be a linear combination of this or the left hand side that corresponds to the vector 5, 10, 1, and 4. So this is what they mean. There has to be a linear combination in order for the solution to exist on a two-dimensional space plane. In this particular system, if you solve it, you're gonna find out that there is no solution where all the four lines intersect at a single point. So the redundancy and inconsistency among the equations demonstrate that the right hand side vector, so this one here, is not a linear combination. So it's not a linear combination of x and y, so if you have a system and then you can find a linear combination of the equations for the right hand side vector, then you have a solution in a two-dimensional space for this type of system. When you have the system has to this is specific for four linear equations in two unknowns, let's say x and y. Thank you for watching. Please subscribe and comment.